Oh, hey there, Math 9. Well, in our next installment of rational numbers, we're going to go into lesson 2-3, which is problem solving with rational numbers in fractional form. So, what does that specifically mean? That means that we're going to add, subtract, multiply, and divide fractions as they come up in their many forms. They could be proper, they could be improper, they could be positive, they could be negative. We'll deal with them as they come up. In the first case, your example is 3/8 increased by a quarter. Now, when we're looking at things in terms of eighths and things in terms of a quarter, combining them is as simple as making sure that we keep both fractions in the same terms of reference. That's a fancy word for saying that both have to be out of eighths. That goes back to that pizza analogy, and I used to tell my grade eights, if I divided a whole pizza into thirds to sit down and eat it, and you divided yours into quarters, how would we share? How would we know we were getting equal number of pieces of pizza, much less share with friends? We'd have to chop those pizzas up in a way where they were out of twelfths, and then everybody would get a slice the same size. So if this is eighths, everything has to be eighths. 3/8 increased by 2/8. And that gives us 3 plus 2 out of 8, or 5 out of 8. Not bad. You could get a negative fraction with a positive fraction. And at first, when you look at this, 1/2 looks smaller. But if you think in terms of being out of 10, that would be more like 5 out of 10, wouldn't it? It's a lot larger than you think it is. Make it out of 10, then look at it. This is negative 5 out of 10, increased by 7 out of 10. When you go to combine these, you've got negative 5 plus 7 out of 10, which is negative 2/10. Positive 2/10. Whew, caught myself there. Which equals 1/5. Remember that you have to, let's see if I can fit it, there we go. You have to reduce the top and bottom if they have a common factor. 2 and 10 are multiples of 2, so you have to divide that out. 1/5. And if you divide 2 by 10, you'll get a 0.2. And if you divide 1 by 5, you get 0.2, which proves that they're equivalent fractions even though you slim them down. And I call that the calculator test. You may be faced with an improper, a mixed number, like you see here. And my advice is you can take one of two paths to do it. The one path that works out pretty well each time is when you put everything in terms of improper fractions. Now, if you remember the technique, you multiply these, and then you just add in the top. 3 times 3 is 9, plus 2 is 11. Now, if you remember that technique, raise this a little bit here, it'll serve you really, really well. So just multiply these, and then just add in the top. You have to put it over the denominator that was originally there, over 3. Otherwise, it won't work. And the proof is 3 goes into 11 3 times with 2 of 3 remaining. So you get your fraction back. And that proves that it was a valid technique. Provided you could do the improper fraction, you have to look at your next challenge, which is a plus minus condition. Well, that's just really subtraction. So let's see what we have after we recognize that it's subtraction. You're adding on negativity. If you think about that, that means you're going left on the number line. And to go left on the number line from, let's say, something like 0 is to go in a negative land. So let's see if we can get this. 2 times 6 is 12. Added to 1 is 13 over the original 6. Now, if you notice in the technique, I didn't look at any of the negatives. It's good in your mind to almost ignore that that's there, because we know that this is going to be negative. So just multiply the 2 by the 6 and add in the 1. Worry about the negative afterwards, because the whole fraction was negative, so the whole improper fraction is negative. And there it is right there. There's your subtraction. When you go to do the next step, it's 11 over 3, 13 over 6. Quick corrective step is to make sure everything is out of 6, because the first multiple of 3 and 6 is 6. Just here, I'll do a quick little multiplication table. 3 times 1 is 3. 3 times 2 is 6. 6 times 1 is 6. 6 times 2 is 12. The first thing they have in common is 6, so that's their lowest common multiple. What we have is 22 over 6 decreased by 13 over 6, which is good for 9 over 6. How many times does 6 go into 9? It goes in 1 time with 3 out of 6 remaining. Now, when I see 3 out of 6, I just reduce that. And I say that is like a half. Just have to speed a few of these along. There's a lot of examples here. I'd love to hit them all, but we'll see how many we can get through. Negative 2/3 decreased by negative 5/6. Let me give you an analogy for this. It always made sense to me, especially when I was a little guy, like you. You're going left on the number line, which is what negativity is. So you're going left, and then somebody says, no, your other left. What does that mean? Well, I was already going left. I was already going into subtraction land, and you told me not to. So what did you mean? Because if I'm going left and you tell me you're not going left, let me think about that. No, your other left. What, you mean you want me to go right? Interesting little way of thinking about it. Double negativity, a minus minus becomes a plus. So if you were going left and you were told to turn around, you'd go right. That's like adding. So 2 negatives make a positive. So you go in the other direction. Now that's a little bit of a simplification. As soon as you see something like this, you can just simply write that this is adding. It's just positivity. Negative 2/3 plus 5 over 6. Let's adjust this so that it's out of 6. You have negative 4 over 6 increased by 5 over 6, which is negative 4 plus 5 over 6, 1/6. Done. Not a bad little example. You may get, when you're looking at 2 rational numbers, you could get a negative proper fraction. And by proper, I mean that the top is apparently smaller than the bottom. And on the other side, you can get a mixed number. A couple of ways to go about this. You could add the quarter part to the negative 1/3 part. I say keep it simple. Put everything in terms of just sort of a natural looking fraction. Either where the numerator is put straight over top of the denominator, or you have an improper fraction. I'm looking at this right now, thinking to myself, I am going to express this as an improper fraction. First chance I get. Because it's easier to add fractions when when there's just one thing over top of another. So a plus minus, in my mind, you're adding negativity. Oh, that means you're going left on the number line. So that's subtraction. And then I simply look at converting this. 2 times 3 is 6, plus 1 is 7. 7 over 3. There we go. Now here's that example I had about pizzas, and I've got quarters, and my friend has thirds. 3 and 4, when you look at their multiples, 3, 6, 9, 12, 4, 8, 12. That's the lowest common multiple they have in common. It's not that you couldn't go to 24, but you just would have to reduce your fractions if you went that far. Let's save time. And just go to the lowest common multiple. That's less work. Negative 3/12 minus 28 over 12 is negative 31 over 12. So you've got kind of a whopper of an improper fraction. It's not really that bad. Sort of look at it as 31 divided by 12. Don't worry about the minus sign. You know the answer will be negative because the top's negative and the bottom's positive. When I look at this, I think 31 divided by 12. Well, it can't go really more than 2 times. That's 24. Geez, what's 31? How far apart are 31 and 24? Oh, they're 7 apart. 7 out of the original 12. Well, because this was a negative divided by a positive, I knew the answer was going to be negative. And that's all I really had to do. Pretty neat how that works out. I like going to a mixed fraction after. It's just less work. Improper fractions you can use with proper fractions, and you can kind of get the job done a little bit easier. If you have to go to a mixed number answer, just do it last. Save yourself time. Let's look at a few of these. As I said before, I don't really have a lot of time for the estimates. This is multiplication, and this is where a lot of the work backs off, because when we multiply, we don't have to get common denominators. Here's a neat example of why this is so. Just a quick example, and I'll erase it. If you have a whole value, and you took a half of it, you would have this much. And if you took a half of that half, you would have a quarter. So 1 times a half times a half. Let's put this 1 over 1. That's interesting. That's 1/2 times 1/2, which equals 1/4. Neat. I can multiply straight across. That is exactly what I'm going to do. Turns out that with multiplying and dividing, you will see that you can multiply proper fractions and improper fractions straight across. And any reductions you need to do, you just deal with it. I like this little undo feature. Save me a little bit of time. All right. 1/3 times negative 4/5. Here's the secret. It doesn't matter if you make the numerator or denominator negative. The fraction on the left was positive and the one on the right was negative. Your final answer is going to be a negative fraction. Here's a little piece of advice. Just leave the negative sign by the numerator. It'll save time, and it's quite honestly just easier to remember. You were going to get a negative fraction anyways. This is 1 times negative 4 over 3 times 5, which is negative 4 over 15. And there's nothing to reduce. 4 and 15 don't have a common factor. The next example, make it improper. I'll just do a quick step here. 2 times 2 is 4, plus 1 is 5 over 2. When two things are in parentheses, it really means you're multiplying them. So let's finish this off. 3 times 3 is 9, plus 2 is 11. 11 over 3. Okay, we've got a whopper of an improper fraction here. We've got 55 over 6. Now, here's where a little bit of rote knowledge or memorized knowledge of times tables works out, because 6 times 9 is 54. So your answer is 9. And if you got to 54, you didn't quite get to 55. You had 1 left over. 9 with 1 left over out of the original 6. And we've done a few examples like that in class. Do that one just kind of quickly. 4.5 divided by 2 1/4, negative 2 1/4. 4.5 is like 4 times 2, 8, plus 1, 9 over 2, divided by, think of that as 8, plus 1 is 9, 9 over 4, and remember to call it negative because that was a negative sign there. Now, if you remember back to grade 8, one of the tricks about this was when you see division, you flip and multiply. Now, interestingly enough, with a couple of my students, we were working on this just a couple of days ago, and they weren't certain about who to flip. You flip this fellow here. The way this is written, it's 9 halves. You write the division as multiplication. You flip the 4 ninths, and this is negative. What you have is negative 36 over 18. Now, there's an interesting technique that we could have used called cross-canceling. I'll go back and show it once the question's done. I'll just do a little bit of erasing here. We'll do this the long way, and then I'll go back and show you a couple of steps that could have sped things up. 18 goes into 36. Well, 18 twice, that's exactly what the doctor ordered. There we go. And this is negative. This is positive. The answer is negative. Now you say, well, what could have been easier than that? Well, I actually had to stop sort of and think, right? It could be late in the day, 36 divided by 18. You just forget. Some of these examples will make you think even more than that. Let's go back just a little bit here. If you know cross-canceling, what you realize with it is that numbers that are in the numerator, if they're across from numbers in the denominator, can be canceled. Here's the proof. It doesn't really matter what order you multiply in. This is like 9 times negative 4 over 2 times 9. Now, if we rearrange this a little bit, it doesn't really matter what order you multiply in. Let me show you something here. Let me just write this as 9 times 2. It really doesn't matter, does it? Still would give me 18. Do you notice how these are right on top of each other? At that point, you say, wait a minute. They're being used to multiply, and they're directly on top of each other. At this point, they could cancel out. 9 goes into 9 one time. Look at that. And while I'm looking at it, 2 and 4 are factors of each other. If I divide a 2 out of each one of those, look what remains. 1 times negative 2 over 1 times 1. Negative 2. Now that looks kind of fancy, but it got to the answer really quick. If I undo these steps, And I'll show you what I would be thinking of as soon as I saw this. I would look at this 9 and this 9 and say they cancel each other out and become ones. And 4 and 2 are factors of each other. The biggest thing they have in common is 2. I'm going to divide a 2 out of each one. Now don't forget about the minus sign, but what you have is -2 remaining. And that's it. You could have done the question in one step. When it comes up, I'll simply go after that right away. -3/4. Now remember, multiply. And this fraction gets flipped. You look to see if there's any cross-canceling. There really isn't any. So you say, okay, this is 15. These negatives will cancel out, so I'll just scribble them out, over 8, which is equal to 1 and 7 over 8. So remember, that becomes multiplication, and these numerators and denominators, they exchange positions, but you've got to leave the lead fraction alone. There's nothing happening to it. Now our lesson has a couple of word problems, which we'll go through a little bit quicker, not too much quicker. There's a newspaper example. Mark has 24 newspapers to get out. He delivers 3/8 of them here and then 2/3 there. Okay, how do you approach a problem like this? Well, I see 3/8 of. That tells me, well, what's going to happen here? Multiply, divide, subtract. Oh, of means multiply. So that kind of gives me a game plan for this question. I get a flavor for it. 24 newspapers, 24 over 1, times 3/8. And here's where that cross-canceling comes in handy. 24 and 8 are multiples of 3. I can divide out an 8 from each one. Well, that's neat, because now I know he's got 9 papers. He goes to the next building and he delivers 2/3 of the remaining amount. This is why you want to remember about your cross-canceling and putting any integer value over 1. 9 and 3 can be cancelled, cross-cancelled. Divide out their greatest common factor, which is 3, and you get 6 as your answer. Now that's not where the question dies. The question says, how many papers does he have left to deliver? You have to sort of think, because you've had a couple of answers pop out here. Now stop and think about what they said. He delivered 9 to the first building, and I like to scribble, right? 6 to the next building. He had 24, and he delivered 15. 9 and 6 is 15. Oh, he's got 9 left. There you go. There's your answer. Pops out into your lap. Not too bad. This is a monthly budgeting question. And again, this is sort of like an of question. A third for food. One of those family budget type ones. They can be a little hard for students to sometimes relate to. But you'll be going to college one day and you'll have to pay attention to this. A third for food, a quarter for rent, a fifth for clothes, and a tenth for savings. And that can be the hard part, is remember to save money. In a question like this, the whole $6,000 is chopped up into these piles. So you have to say, well, what's the size of the pile? This isn't a decreasing question. This is just how much does each represent. 1/3, let's zoom in. I'm going to need a lot of space. 1/3 of what? Well, it's 1/3 for food. 1/3 of 6,000. And we've got a quarter for rent of the 6,000. Notice they're all out of 6,000. because when you look at your monthly budget, you're looking at everything as a piece of 6,000. So don't change the 6,000. A fifth for clothing. That's a pretty good clothing budget. Wow. Although it is a family, to be fair. And 1/10 for savings. College fund. Call it what you will. Now here's where the cross-canceling will come in super handy. I just want to change my pen color. So we'll go, let's say, black in this case. One third of 6,000. 3 and 6 strike me as being sort of multiples of each other. If I divide a 3 out here, that becomes a 1, and that becomes a 2. Well, that looks like it's 2,000 over 1. That's $2,000. Now, 4 going into 6 might be a little bit hard to see, but how many, if you think about an hour, and if you divide it into 4 equal things, what would those be? I like to think about things we know. Oh, 15-minute periods. There's 4 15-minute periods there. So if I cross this out and divide by 4, that makes that a 1, and that makes that 15. So this is $1,500. Works pretty well. Here's another technique. How many times does 5 go into 60? You don't often think about this, but there's 5 12-minute periods in an hour. This becomes a 1. This becomes 12. $1,200. Now, if the cross-canceling didn't come to you right away, you could just multiply the tops and the bottom straight across and reduce. But these are some neat little techniques you can sort of get away with. What do 10 and 6 have in common? Nothing. But 10 and 60, I can divide by 10. All right, so that becomes a 1, and that becomes a 6. I need a little bit more room. There we go. So what we're looking at is $600. All right, so their budget has popped out. It's $2,000 for food, $1,500 for rent, $1,200 for clothing, and $600 for savings. So what's left? Well, you have to do a little bit of the math, and you say it's $6,000. So when you combine these, let's see here. I like to do this little technique. That's $3,500, and that's $1,800. 35, 18. If you can do these in your head, it's commendable. But 35 and 18, it's perfectly fine to approximate. But if you need to, go ahead and pick up your calculator. $5,300. Well, they have a $6,000 budget. That would only leave $700 remaining if we subtract the 2. That's pretty tight, but I bet you they make it work. Okay, in your final couple of examples here, what you've got to do, it's not my intent to solve all of these, but just to show you how to approach them. If you have two values, let's say A, pen back. You have A minus B equals C. How do you get this missing value? Your answer came from something going on over here. So what do you got to do? First, you have to erase like mad. There we go. Another easy way to think about it. If we had 4 minus 2 equals 2, how could we get back to the 4? This is about getting you to think about opposite operations. So if we had to subtract to get the answer, how do we get back to what we had? We would have to add these to get back to where we were. 2 plus 2 equals 4. So going back, there we go. Do a little erase. Some number decreased by something equals 5, 6. Now if you've done a little bit of algebra, that could help. Some number, we could say y is equal to 5, 6. And this is another way of proving that you would have to add 1.5 to both sides just to find out your answer. There's a little bit of algebra proof for you. If your algebra is a little bit rusty and you haven't done that, just remember that the step in the question was subtraction. So what you're going to need to do is you're going to need to do addition. Switch colors here. 5, 6 plus 1 and 1/2. So we could say this is like 5, 6 plus 3 over 2. Multiply by 3, multiply by 3, 5 over 6 plus 9 over 6, 14 over 6, or 2 and 2/6, which reduces to 2 and 1/3. Now it took me more room to write that, but this is the general approach to these questions. If you have a question such as this, the game plan for this is to find what's missing there. Take a look at this. You're going to have to do the opposite. Instead of adding something to 2/5, the opposite is to take away the 2/5 to figure out what it was. So what have we got? We've got negative 3/10 decreased by 2/5, and let's see if that turns out to be right. We need to do the opposite operation. And if you've done algebra, you'll see that it's a game of opposites to find the missing value in this case. Multiply by 2, multiply by 2, negative 3/10 minus 4/10, negative 7/10. So if this is true, it should stand up to scrutiny. It should work. So does 2/5, I just have to borrow space here, grab a new color. Does 2/5 minus 7/10 equal negative 3 over 10? Probably does. As soon as we adjust this, we get 4 out of 10 decreased by 7 out of 10. 4 minus 7 would give us negative 3 out of 10. So our opposite approach works. When we get down to the bottom, it might look daunting or challenging to you, but it isn't, because all they've given you is a question where you have to do the opposite. If you were multiplying with this, then you need to divide with that. So your answer is going to be 2 1/4 divided by negative 1 3/8. and I'll let you work that one out. Okay, and we're back. For our last example, we kind of have a doozy here. We are dividing by 2/3 to get this final value. So how do we figure out our final answer? In algebra, if you've had a chance to do that, if you are dividing by something, you have to get rid of it by timesing by something. That's a little hint. Whatever we had was divided by 2/3 to get our answer. So we could say it like this. I have no idea what it is, but I had to divide it by 2/3 to get our answer. So the opposite step of dividing by 2/3 is timesing by 2/3. Now, if your algebra is a little rusty, you haven't done this in a little while, don't worry about it. Just remember that we have to undo. We have to do an opposite thing. So we'll go back a little bit here. I'll do the undo. And we'll take the answer as being negative, there we go, negative 3/2. Let's speed this along just a little bit by saying 3 times 2 is 6, plus 1 is 7, negative 7 over 2. And let's multiply. We're not dividing by 2/3. Now we're going to multiply because that's the opposite job. And this time we're going to multiply by 2/3. Now I know you're thinking about flipping and dividing. Let's save that until after, until we figure out what our answer is. Because we need to do the exact opposite. Dividing by 2/3. Think about it this way. Dividing by 0.666 repeating, or 0.66. Let's multiply by that and see what we get. We get negative 14 over 6. Okay, now as a mixed number, that's negative 2 and 2/6, which I could reduce further, negative 2 and a third. But I'm interested in this, because this is easy to multiply with. Let's see if that is the correct value. Is that right? Basically negative 14 over 6. Does that equal our answer? Well, quick way to find out. I just have to do a little scroll. Need a little more room here. Okay. Does negative 14 over 6, when divided by 2/3, does that give me negative 3 and 1/2? Well, I already saw that negative 3 and a half was the same as negative 7 over 2. Okay, they're the same. So let's see if this turns out to be right. Negative 14 over 6. Now this is called a check. We are just doing the original question, right, with this answer we figured out. Let's see. Well, we can do a cross cancel there. 2 and 14 go into each other 2 times. So I'm going to divide out a 2. Becomes a 1. 14 divided by 2 becomes a 7. 3 goes into 6. 3 divided... 3 is their common factor. I'm dividing a 3 out. Let's make this a 1. Let's make this a 2. So I have negative 7 over 2. So this must have worked. That's what I expected to see. That's the same as the negative 3.5 we started with. So if we zoom and we look back, well, that works. Because that's our original question. Go back here. Negative 7/2 totally works out in our question. So our check confirms that our final answer, negative 14 over 6, when divided into 2/3, gives us negative 7.5. So the essence of our question, bringing it back there. There we go. We're back to this. And our answer, negative 14 over 6, works. That's what I wanted to show you. Okay, and that's a fair assignment, this one that we've gone through. And it's adding, subtracting, multiplying, dividing using rational numbers. So I hope this lesson was able to, little video lesson was able to help you out. Okay, Mr. B, out. You guys have a good one.